Today's notes, we are getting into the bulk of what we are doing this unit, which is similar triangles or similar figures. Okay, so last chapter we talked about congruent triangles or congruent figures. Today we need to talk about what does it mean if two figures are similar. So starting with this definition, two figures are similar if they have all corresponding angles congruent. So all of the corresponding angles have to be congruent. And all corresponding sides are proportional. What I mean by that when I say proportional is they have the same ratio. So if we were to make a ratio for all of the sides, we would end up with the same ratio. This is the notation. So that symbol means similarity. So the basic idea with similarity, and I want you to write this down, is that we are taking a figure and we either enlarge or shrink it. So if we take a figure and we enlarge it or we shrink it, our sides are going to be proportional. They're going to change by the same amount, and our angles will stay the same. So here is our first example. We have this triangle is similar to this triangle. And what that example is this is called a similarity statement. Just like we would have a congruency statement. Similarity statement will tell us which angles are congruent. So angle J, the first angle, is going to be congruent to angle P. Angle K, the one in the middle, is going to be congruent to angle M. And angle L then is congruent to angle N. So that's the first piece above. All of our angles are congruent. Our sides being proportional then, like we wrote above, they have to have the same ratio. So that's what we have over here on the right side, is we have the ratio of the sides. And again, our statement will tell us which sides go together. So JK, first two letters, is going to go with PM. MN, the second and third, is going to go with KL. And then we see that JL, the first and third, goes with PN. How do we feel about that? Okay, great. This next example, we are not even going to look at the figure. I don't think the figure is needed at all. We're just going to look at this statement. And we're going to write out the congruent angles, and then we're going to write out our sides. Congruent angles. Angle R, the first angle, is going to be congruent to angle Q. Angle S, the one in the middle, is going to be congruent to angle P. And then angle T, the last one listed, is going to be congruent to angle U. The sides then, we have three sides we need to relate. I always start with the first figure, and I'm just going to go in order. So RS is the first and second letter. S and T is the second and third. And then R and T is the first and third. If we follow the same order on the second triangle, the first and second is QP. Second and third is PU. First and third is QU. Any questions on that? Okay, we're not going to do the second example. It's the same thing, except you have one more angle, one more pair of sides. So similarity does not just apply to triangles, it applies to any kind of figure. So in this case, a quadrilateral. We're not going to do that, though, again, just in the interest of time. We feel okay? Okay. I would like you to do this one. So do this one at the top. It gives you a figure. You don't need the figure. You don't need the figure. All you need is this part right here. Take a minute and complete that one, please. This is what I got. Did you guys get the same thing? Okay, one thing I want to point out to you is when we're looking at these triangles, triangle RTU is this triangle right here, and we are comparing that triangle to the whole thing, RQS. So basically what we did is we took this blue triangle and we blew it up into the red triangle. So when we took the blue and we blew it up into the red, the sides changed by the same number, maybe they doubled, but all of the angles stayed the same. So if we wanted to mark those angles that were congruent, if you could do this with me, please. Angle R is congruent to itself. Angle T is congruent to angle Q. And angle U is congruent to angle S. We're going to finish this page and then we will take a break. Sound good? Okay. So, moving down. We're going to look at this example right here. It says in the diagram, angle R is congruent to angle X, angle S is congruent to angle Y, and angle T is congruent to angle Z. So let's mark that real quick. Angle R is congruent to angle X. Angle S is congruent to angle Y, and angle T is congruent to angle Z. Now we are going to write a ratio of the corresponding side lengths as a statement of proportionality. That's what we've been doing. Then we're going to plug the numbers in. On the first triangle, I have three sides. I have RS, ST, and RT. Now, like similarity, we need to follow the same pattern. RS is between these two angles. The same angles on the other triangle is side XY. ST goes from 1 dash to 2. So if I go 1 dash to 2, that is YZ. And then RT is 2 to the outside tick mark, 2 to the outside is ZX or XZ. So this, if you want to write this down, is called a statement of proportionality. Now what we want to do is actually put all of those numbers in. All of those numbers in. So RS is 20, ST is 30, and RT is 25. Then if I go to the other triangle, XY is 12, YZ is 18, and XZ is 15. Ooh, sorry. Okay, if we simplify these, what can I divide this first fraction by? This first ratio? 4. Okay, so if we divide by 4 here, we're going to get 5 over 3. Second one, what can we divide by? 6. And we get 5 over 3. Last one, divide by 5, and we get 5 over 3. And they are all equal. And they should be. We said similar triangles, the sides are proportional. Write that down. Sides are proportional. And what that means is they have the same ratio. So all of those ratios simplified to the same number. Now, that number that they simplify to is an important number, and that number is called the scale factor. The scale factor. And the scale factor is just the ratio of the sides. That's it. Okay, I lied. We're going to do one more example, and then we'll be done. I know, I'm sorry. One more example. Go to the next page. I just want you to do this example right here. This example right here. I would start, if I were you, by looking at this statement right here and figuring out which sides go together. So start with your statement of proportionality. Which sides go together? So far, this is what I've done so far. So I suggested you set up a statement of proportionality, the sides that go together, then plug in whatever numbers you have. Since we need to find these missing sides, I called them x and y. But ultimately what's important is for you to recognize that the 6 and the 9 go together. So if we take that ratio and we simplify it, we get 2/3. That is called the scale factor. Now, to find those unknown side lengths, you could use the 2/3, you could use the scale factor, or you could use this statement that we have above. I'm lazy, so I like to use the statement because I don't have to simplify anything. If I set these two equal, I can find y. So if I do 6 over 9 is equal to 4 over y, I can use that to find y. So this way will give me 6y is equal to 36, so my y is equal to 6. So on my figure, that is QR. So I know that QR is 6. To find x, I'm going to use that ratio and then one of the other two. So I'm going to use this one. Set those two equal. So I get 6 over 9 is equal to x over 12. And again, cross multiply. So I get 9x is equal to 72. If I divide by 9 then, my x is equal to 8, which is JL. So JL is 8. When we come back from our break, we're mostly going to be doing part B, setting up proportions and solving them. Questions for me? Okay, for the rest of these notes, we have 4 problems to do. I'm going to do 2, then you're going to do 2 with the person next to you. All we are doing is similar to this example, part B. So using a similarity statement to find some missing quantities, like missing sides or angles. If we look at this first example, it says in the diagram below, blah, 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 and we need to find x and y. So on the figure, we need to find x and y. Anytime you see something like this, start with the similarity statement. Don't even look at what the triangles give you, but write your statement of proportionality. So start with that every single time. First triangle, I have sides AB, BC, and AC. Looking at the second triangle then, the corresponding sides are DE, EF, and DF. Then what I'm going to do is actually fill those in. Now that I know which sides go together, now I'm going to fill in with the sides I actually have. So AB is 8, BC is 12, and AC is 10. DE is 10. EF is X. And DF is Y. If we have 2 variables, X and Y, we're going to need 2 equations. Always use the ratio that you know both of the numbers for. So for the X, I'm going to do 8 out of 10 is 12 over X. For the Y, I'm going to use that 8 over 10 again is equal to 10 over Y. And then we're just solving those proportions. So for the first one, I get 120 is equal to 8x. I divide by 8. I definitely don't know what 120 divided by 8 is in my head. So can somebody do that and tell me what you get? 15? Thank you. Manny?
Couldn't you like simplify it, or do you not have to?
You don't have to, but you certainly could. Yeah, you definitely can, but you don't have to. If I solve for y, I get 8y is equal to 100. If I divide by 8, again, I don't know what that is. Ben, do you have me on that one too? Somebody? 12.5? Thank you. Can anybody think of a reason why I might suggest that you don't simplify the 8 out of 10? Besides that I'm being lazy? What could go wrong? If you simplify wrong, do we see that we would find x and y wrong then? So, okay, we're going to do one more together, and then you will have 2 to do, and then that will be it. In the diagram, LMN and OPN are similar triangles. So again, just start with which sides go together. I have LM, MN, and LN. And then OP, PN, and ON. Do you see how we don't have all of the sides? So we just need to be careful with that. LM is 18. OP is 12. MN is 27. PN is 4x plus 6. LN we don't have. ON we don't have. We don't need to put anything there. That just means we don't need those sides. We don't have them, so we don't need them. And now we're just going to cross multiply. I definitely need a calculator. Okay, 12 times 27. We get 324 is equal to 18 multiplied by 4x plus 6. Remember that 18 has to be distributed. That's where sometimes we tend to go wrong. So we get 324 is equal to 72x. Add 108. If I subtract the 108, I get 216 is equal to 72x, which means our x is equal to 3. How do we feel about this idea? We're okay? Manny?
You have to plug it back in.
Nope. It doesn't really tell us what we're looking for, so I'm just telling you you're looking for x. Thank you for asking. Okay, I would like you all to flip to the next page. These are the last 2 examples that we're doing. So I would like you to use your best judgment, not best judgment. I would like you to try both of these. Move your desk together with the person next to you if you haven't already. Take 5 minutes to do both, please. I would start both of these the same way by setting up your statement of proportionality. The key to this first one was figuring out this side GK, which I think a lot of you did. GK is this whole quantity, so it's x plus 6. And then when we cross multiply, remembering that this 8 gets multiplied to the x and the 6. So we end up with x equals 4. Did that one go okay? Okay. The second one is definitely the tougher one. If you start out with your statement of proportionality, the issue we run into is seeing we have all the sides of one triangle, we don't have any of the sides of the other triangle. So how do we find these sides on the second triangle if we don't even have a single one? We have the scale factor though. So we know that all of these fractions have to simplify to 2/5. So what you can do is take any of these fractions and set them equal to 2/5. Cross multiply, find the missing side. So those are the sides that I found. Manny?
On the test, we have to do that and show work, or we can just like do it mentally.
You have to show some type of work. No, you don't have to show that you set them equal. To address that, I think what I'm about to say is what you're thinking, but let me know. Someone over here asked, if I notice to go from 2 to 12, I just have to multiply by 6. Can I multiply by 6 here and get a side of 30? Is that kind of what you're thinking?
Yeah.
Totally, you can do that. Just show me that you multiplied by 6. And then to go from 2 to 10, you multiply by 5. So again, multiply by 5 again, and you get this side of 25. You're cross-multiplying just in a different way. You're still solving. And then ultimately, remember, you had to find the perimeter, which is 75 units. Okay, your homework is going to be similar, except you're going to have systems and you're going to have factoring. So you are going to have to do that. Do you have any questions for me from today's notes?